Alright, so for now, our video today is going to discuss the double angle identity. Alright, so which is the third set of the identity that we have in our A2 syllabus. Okay, so for the double angle identity, it is actually the most commonly used identities in most of our questions, especially when they are asking you to do the integration. Alright, so usually for integration, we have a lot of identities from this part, the double angle identity. Okay, so for double angle identity, generally, if you want to memorize it right, you can use your knowledge in the previous set of identity, the compound angle. So as an example, for my compound angle, right, I'm having sine A plus B, which is equals to sine A cos B plus cos A sine B. Alright, so to change it become double angle formula, you just need to replace the B by using A. Okay, so you replace it by using A, replace it by using A, and you replace it by using A. So if you continue, sine bracket A plus A, you'll get sine 2A. Equals to what? Equals to sine A cos A plus cos A sine A. So cos A sine A sine A cos A are the same thing, right? And eventually you'll get 2 sine A cos A. So this is how you get the double angle formula. So sine 2A is equals to 2 sine A cos A. Alright, so this is actually how you memorize it. It is actually related to the compound angle formula. Alright, so again, for me, myself, generally I already remember it because of many times. So that's why I remember it. Yeah, right. So how about cos 2A? So for cos 2A, if you get the equation, okay, from double angle formula, then you'll have cos squared A minus sine squared A. This formula, the first one, this formula is actually come from replace the B in compound angle to get this. Alright, but for cos 2A, if you look at our notes here, they are having another two parts. This one and also this one. Alright, there are another two. So in total, there are three different equations. So cos A, sorry, it should be cos 2A. I'm so sorry for that. Okay, so I'm having cos 2A here equals to cos square A minus sine square A. How can I get the other two formula? Alright, so to get the other two formula, very easy also. From the original formula, you change the cos square by using 1 minus sine square. So you have cos square, which is 1 minus sine square, right? Because cos square plus sine square equals to 1. Therefore, cos square, you can rewrite it become 1 minus sine square, then minus sine square again. Okay, so from here, what do you have? If you simplify, you'll get 1 minus 2 sine square A, which is the last equation that you can see here. Okay, and after that, how can you get the second equation with the cos one? So the second equation with the cos one, you do the other way around. So that means instead of replacing the cos square, you replace it by using you replace the sine square. So sine square A is what? 1 minus cos square A. So if you simplify it, you have 2 cos square A minus 1, which is the second equation that you see in our equation, in our formula here. Alright, so the first one comes from where? Comes from the double angle formula. And then the second and the third one, you just try to substitute the sine square or cos square by using the 1 minus sine square or 1 minus cos square. Okay, alright, so this is how I try to memorize and try to link it. So for cos 2a, it will be more complicated because you're having 3 different types of formula. Okay, and all this you have to memorize it. Then for tangent 2a, also the same thing. You get actually the answer from the compound angle formula. Alright, so we're having 3 sets here, sine 2a, cos 2a, and tangent 2a. And then cos 2a is the most important one because as what I told you just now, most of the formula for cos 2a will be used in the integration that we are going to learn later. Alright, in chapter 5. Okay, so for double angle identity, please make sure that you try to memorize it. Okay, so there's one thing that I want to let you know for double angle formula, right? Okay, so I think I told you before also, when you're having all the trigo identity, you can adjust it according to the question that you want to answer. So as an example, when you want to adjust the trigo identity, you cannot adjust the pattern, but you can only adjust the angle inside the trigo. So as an example, for this one, I'm having 2a, I'm having a and a here. How about if, let's say, I want to expand sine 6a. If let's say I want to get sine 6a, then the pattern is still the same. 2 sine something cos something. But the something here will become 3a. Because 2a become a, which is half of it, right? So if I'm having 6a, then I'm having 3a and 3a. Understand what I say or not? Okay, so you are freely to change all these like according to the pattern of the double angle identity. Okay, so another example, if let's say I'm having originally cos 2a is equals to 1 minus 2 sine square a. Alright, so you can see the angle is 2a and a. Okay, if let's say in the question I want to, I'm having sine square 2a. So can anyone tell me if you want to rephrase it, it become cos? So what is the angle inside the cos here? It will become cos 4a. Okay, so please take note of this because this concept is very important. Again, in solving a lot of questions in the past year question in the past year, right? So the books might not tell you that this is important, but please make sure that you're aware of this. Okay, the angle you can adjust, but you cannot adjust the pattern of the formula itself. Like cannot change the square become cube, or cannot change the 2 become 3. All this value cannot change. All right, you can only change the angle in the trigo. All right, so again, try to memorize it, and then proving part as usual, I will skip it. If you're interested, you can have a look here. Okay, so let's learn how to apply the double angle formula from the basic first. Alright, so for example 13, it is a very basic example for double angle formula. Okay, so first they give you tangent theta equals to 3 over 4. And then they tell you that the theta is acute angle. So acute angle means that when you put in the value, it should be always positive. Find the exact value of tangent 2 theta and also tangent 4 theta. Okay, so let us start with this. Okay, so for us, if you want to get the value for tangent 2 theta, what is the formula? It should be 2 tangent theta divided by 1 minus tangent square theta, right? Okay, so what's the value for tangent theta? It is given 3 over 4 divided by 1 minus tangent theta square. So it should be 3 over 4 and then you square it. So this question very straightforward because you just apply, substitute the value and also use the calculator to get the answer. So you should get 24 over 7. Okay, and after that, when we go to part number 2, part number B. Okay, so from here, you already know that your tangent 2 theta is 24 over 7. All right, according to the double angle formula. Okay, then how about if I want to get the answer for tangent 4 theta? Okay, so again, just now you're having 2 theta, right? So now you're having 4 theta. The formula will be same. Okay, it will be 2 tangent something divided by 1 minus tangent square something. Because of your original question now become 4 theta, therefore here it will become tangent 2 theta, tangent square 2 theta. Okay, so what is the value for tangent 2 theta? You already get the value just now. Tangent 2 theta is 24 over 7 divided by 1 minus 24 over 7 square. Then again, what do you get is negative 336 divided by 527. All right, so this is what we get. Okay, so this is what we have for example 13. How are we going to get the exact value for tangent 2 theta and 4 theta? By using the double angle formula. Okay, and then after that, we might apply the formula in the other way round. So what is the meaning of in the other way round? Okay, we can have a look for example 14. But again, example 14, there are 3 parts here. I will just show you example and then you try the other 2 examples yourself. So do it in the other way around means that when they want you to get the value for 2 sine 22.5 cos 22.5, the angle 22.5, without using calculator, you cannot get the value, right? Okay, but if you know that this equation is in the pattern of 2 sine A cos A, you can actually change it become sine 2A, right? Which means you can change this equation become sine 2 times of 22.5. So when you multiply 22.5 with 2, you'll get 45. And that's why it will be very easy. It becomes square root 2 over 2. So this is we combine, okay? We do it in the other way around. From right hand side, you change it becomes sine 2A. Okay? Then you can B and C yourself also, which is very similar to what I showed you just now. For part B, the answer is negative square root 3 over 2. Part C, the answer is square root 3 over. Okay? So this is how we do it, how we get it. Okay, then example 15. So again, example 13 and 14 are something very simple, just to test you on the concept and very simple idea on the double angle formula. Okay, so now we have a look, how are we going to apply it in the exam style question? So have a look for example 15. Okay, first part, they want you to simplify this identity. So they want you to simplify sine 2 alpha and secant alpha. Alright, so sine 2 alpha, how can you separate it? It become 2 sine alpha cos alpha. How you expand secant out? It will be 1 over cos alpha. So eventually what do you get? You have 2 sine alpha. This is a very simple question. You just expand it straight away. Okay, then now let's continue to part number 2. Okay, so for part number 2, they give you this equation and they want you to find the exact value of cos beta. Alright, so I will start from here. 3 cos 2 beta plus 7 cos beta equals to 0. Okay, so now I want to expand the cos 2 beta. But cos 2 beta, there are 3 formulas here, you know. You're having cos square beta minus sine square beta. This is the first one. The second one is 2 cos square beta minus 1. And the third one is 1 minus 2 sine square beta. So which is the most suitable formula that I should put into our solution here? Okay, then again, you refer back to the question because the question they request for cos beta. Therefore, when I choose only the equation with cos beta. Okay, therefore, I will have 3 multiply with 2 cos square beta minus 1 plus 7 cos beta. If you expand everything correctly, you will have a quadratic equation in terms of cos beta. Okay, then you will realize that, oh, okay, you can actually factorize out this equation and you'll get cos beta equals to 1 over 3 and also cos beta equals to negative 3 over 2. So this one you should ignore it. Okay, but this one you should accept it because negative 3 over 2 means negative 1 over 5. Oh, sorry, 1.5. So there will be no solution for cos beta equals to negative 1.5. And therefore, this is what we should have. Okay, all right. And then do you need to find the value for beta or not? No need, because in this question, they are asking for the exact value of cos beta only. They don't want the beta. So don't go and solve it. All right, so the cos beta equals to 1 over 3 will be the final answer. Okay, so this is one exam style question. In my opinion, this kind of question also seldom come out because it is more towards the easy side. All right, more towards the easy side. So usually they seldom ask you this kind of question also in the exam. Okay, so example, let's continue to example 16 and also 17. Okay, so example 16 and 17 are the questions that they are going to ask you, okay, in the exam. Usually if you look at the question, they are giving you 2 parts here. First part, they ask you to prove the identity. The second part, they ask you to solve the equation. So usually that is the start, okay, for the A-level syllabus, A2 syllabus question in Trigo. Usually, okay? All right. So let's have a look for example 16. Me particularly, I will solve example 16 for you. You try example 17 yourself. All right. Okay, so let's have a look. They want to prove the identity. Okay, so to prove the identity, right? When my equation got compound angle or double angle, I will always start from that. All right, so I will start from left hand side. Because right hand side got single angle, theta only. Then here you got 4 theta, 2 theta, right? Therefore, you should actually try to expand from the left. Okay, so left hand side, I'm having cos 4 theta plus 4 cos 2 theta. Okay, so for cos 4 theta, right? If I want to expand it by using double angle formula, then I can have cos square 2 theta minus 1. So for this cos 4 theta, I will expand it to 2 cos square 2 theta minus 1. So I highlight it in yellow color. Okay, then plus 4. Alright, so for cos 2 theta here, I want to expand it again, okay, using the double angle formula. So it will become 2 cos square theta minus 1. So maybe you ask me, how many times or how far should you expand it? So again, I will look at the question again. So my question only have theta, so that means my final answer shouldn't be in 2 theta. I want it to be in theta. Therefore, cos 2 theta here, I will change it become 2 cos square theta minus 1. Okay, then you can expand and simplify it first. So you're having, okay, cos square 2 theta. If I don't want to make you confused, maybe I will prefer you to change it become cos 2 theta square. Then minus 1 plus 8 cos square theta minus 4. Okay, if you look at the equation here, this one no problem already, this term, because you already have cos something with theta. The theta is already there. Although it is power 4 and we are having power 2, but at least the theta is there already. Then now where's our problem? Our problem is here. I'm still having the cos 2 theta in my solution. Then again, I need to apply this equation again to expand it become only got theta. Understand what I said or not? So I apply this equation again in my solution here. All right. Okay. So when I substitute it in, I'll have 2, and then I'm having 2 cos square theta minus 1, and then square. Minus 1 minus 4 become minus 5, right? So I'm having 8 cos square theta minus 5. Okay, so this bracket, please expand it. You will have 4 cos power 4 theta minus 4 again. Okay, 4 cos square theta plus 1. Then 8 cos square theta minus 5. Okay, and after that, you expand everything. Okay, and try to simplify as far as possible. So like this one and this one no longer available anymore, and that's why you will get 8 cos power 4 theta minus 3. So you double check and see, is it the right hand side answer that they want you to prove or not? I think should be yes lah. Okay. Yeah, so for this one, you will see that I actually adjust my compound angle formula for cos and apply it 2 times in my solution. Okay, so this can be happen. Maybe they want you to apply 2 times or 3 times or more in the same question. All right, so please be aware of all these details. Okay, then now we continue to the part number 2. Okay, so usually for this kind of question now, part 1, when they ask you to prove, right, that means part 2, they will want you to use the result in part 1. So as an example, for part number 2, they ask you to solve this equation. Okay, I want you to compare the equation here. This red color one and this red color one are the same thing, right? Okay, and then to solve this equation, what you need to do is that you have to substitute your answer in first part into the equation. So that means you should have 8 cos power 4 theta minus 3 equals to 1. You usually straight away substitute it because you already proved it in the part. Okay, and after that, what do you get? You are having 8 cos power 4 theta equals to 4. So cos power 4 theta equals to half. Okay, when you want to the root of 4, what you need to do is that you have to consider plus minus sign. So you should have plus minus 1 over the root of 4 for 2. That means 2 power 1 over 4. Okay, 2 power 1 over 4. Why do we have plus minus sign? It is just like square root. Also, when you take square root on your own, right, you have to consider the plus and minus sign. So for all the even number root, you also need to do that. Square root, root of 4, root of 6, and so on. You have to include all the plus and minus sign here. So when you plus and minus sign here, that means that when you go through with the quadrant, right, you accept the answer from all quadrants. Okay, right. So again, I want to get the basic angle first for this example. So the basic angle that I get, they want it in radian form again. Yeah, so they want it in radian form. Therefore, I should get 0.572. Okay, and after that, they want to get the theta. So the theta is between negative half pi until positive half pi. That means you need to go through one quadrant in clockwise direction, one quadrant in anti-clockwise direction for cos. So you should have 0.572 and also negative 0.572. Okay, so this is what we have for our example here. So you can see that I'm using the result from first part and substitute it into the second part to solve the equation. So the question is like this. If let's say in the exam, you're not able to show what they want you to show, okay, never mind. You still can answer part number 2. Don't straight away skip the whole question. Because for part number 2, you are using the result from first part, proving one and substituting. So don't waste your chance to get marks from here. Okay, maybe you cannot prove that. You say, I memang very weak in proving. Then how? Okay, so if let's say you really cannot prove, don't give up. Continue with part number 2 by applying the result in part 1. Just apply, and then you can solve it also. Then at least you still can score some marks from here instead of wasting the whole question. Understand? Okay. All right. So this is what we have for example 16. So just give you an idea how they ask you the question in the exam. All right, so if you continue to example 17, you will see that the pattern is more or less the same. First part, they ask you to prove the identity. So this is the identity that they ask you to prove, and after that, they want you to solve the equation. All right, so for example 17, I will just repeat for you to try your own. Okay, when they are talking about cosecant 2 theta, what can you do? You can actually refer it to change it become 1 over sine. Okay, then after that, only you change become 2 sine theta cos theta, and then after that you continue to try and get an answer. Right, so it's just a hint for you. Okay, you can try it out on your own and see whether you can prove or not successfully. Then definitely for this identity, you have to start to prove it from the left. So because left got double angle, that's the first thing. And also you have 2 terms. Right hand side only got 1 angle, single angle with single term. So the left hand side will be more complicated. You should start from left hand side. Okay, then for part number 2. For part number 2, they want you to solve the equation, right? So by using the hint that I tell you just now, you can solve it very easily. Okay, part 2, the answer is 26.6 degree and also 206.6 degree. All right, so please make sure that you try out this one. If you really cannot get an answer, you let me know, right? But please make sure you practice all this on your own. Try to understand every single detail for this Trigo chapter. Okay? Alright, so for the next video, we are going to learn how to change cos theta and sin theta to a single cos of sine. This is something new. Alright, so we'll discuss this in the next video. Right?